All right, then time's up. Then let's gonna get started. I'm gonna introduce about basis extension analysis for interpretable time series forecasting, which is published on ICLR 2020. Then let's check. Oops, sorry. Okay, then let's read the abstract first. Okay, everybody done? All right. Then I think in this point there is no explicit gap sentence in here, but I think this one should be the implicit gap. I think. What do you think, guys? They explain their novelty of their model structure. And then I make a clear the goal of this journal. Then let's learn the method to effectively decompose time series data. Then say the time series decomposition enables effectively analyze the data. Then let's apply time series decomposition method when analyzing the wearable data. Then Then various models have been proposed for time series analysis via decomposition. Like in Europe's, the paper named Enhancing Time Series Forecasting Models with Implicit Decomposition. This model let ground truth Y decomposition into seasonal ground truth and trend ground truth Y. And then they, and then, hold on, okay. And then let input time series X decompose into seasonal input and trend input. And then they train the model based on seasonal prediction task loss and trend prediction task loss. This means that they implicitly apply time series decomposition during the model training process. And in ICML, the paper named Frequency Enhanced Decomposed Transformer for Long-Term Series Forecasting. They use the model architecture as the transformer. This is the encoder part, and this is the decoder part. And I look at the green part named Frequency Enhanced Block. They applied Fourier transform, capture the time series patterns on there. And then they applied Fourier transform after they divide the input data into key core value parts. And then they try to capture the time series patterns on there. And this means that they explicitly incorporating the time series decomposition into the model architecture. Then why is the time series decomposition used in time series analysis? And the time series decomposition leads to more effectively analyze the time series data. Like, let's check the example in here. There is Kim Hyun Dr. Hyun Kim is in here. I'm First, congratulations about you become a professor in one of the top university in this country. And he become a professor, then he needs to move. He had to buy some new apartment nearby Seoul. So he have to buy some stock to make more money. Then he buy the Samsung stock on this moment, but he was lonely. So he moved on to neighbor to Dr. Huang and then let him to buy Samsung to either. So the two-person buy Samsung stock on this point. And then time is passed. And then in this point, Dr. Hyun Kim think this point is the bottom. So the stock price going sky maybe. So he tried to buy the Samsung stock on more about in this moment. Then he was lonely again. So let Dr. Huang to buy the Samsung stock too. But Dr. Huang has a smart intern named Jae-hoon. Jae-hoon do some analysis. He just decompose the time series data, and then he extract the trend, and then he throw away the trend of the data, and then he extract the seasonality like this. But Jae-hoon do some analysis, then the positive season is almost done. So let Dr. Huang not to buy the Samsung stock in this moment. Then what happens later? Yes, the price is going, the price is just crap like this. So the time is passed. Then in this moment, the Dr. Kim Hyun think this is the top of the moment. So he sell all the money, all the stock to the money. Then he let Hyun Kim let Dr. Huang to sell all the stock with him. But he has a smart guy like Jae-hoon. Jae-hoon do some another analysis like this. Then that he think the negative positive period was really quite long. So that the positive seasonality goes a little bit more. So Dr. Huang let Dr. Huang to buy more stock in this moment. Then what happens later is that the price go up to the sky like this. Okay, and then Dr. Hyun tried to buy again in this moment, but he do one more analysis in this moment in Jae-hoon, and then the season is almost done. So he gonna let Dr. Huang sell all the stock in this point. So what happens here is that Huang's assets going higher, and then Hyun, he lost everything. Okay, and there is one person in here. This is the real story. Then he do what is he bought Samsung in here and here. This is the real story. But what he did is, you guys guess what? I sell all the stock in this moment. So in this point, we have to focus on, in this point, we have to know is that we have to do some analysis based on such as like time series decomposition, like this kind of things, when we do some more tests. Okay, then let's move on to main part. The MVIX was proposed as a model that incorporating time series decomposition into its application architecture. Then this paper is proposed. This paper is published as a conference paper at ICLR 20 and 20. And there is input data like this. Then this input data move into the model. And this model is based on multi-stack structure with stacking connection. And each stack is based on multi-block structure with residual connection. And each block is based on the double output layer with double residual connection. And they can, then this model try to capture the patterns in each stack and block and layer, and then they predict some after horizon period, their horizon, like this. So MBIT's model is composed of multi-stack with double residual stacking connection. And when we have input data like this, then this input data move into the model. Then this model is just existing stacking connection. That is just the normal model architecture. But this architecture is that have only a single focused output, like just single output wave. But they designed a new model like this. Then they have a two way. Like first way is they just print out the focused output, and then they output. Another way is that the backcast output with the double residual stacking connection, because they have two focused output and input backcast output. Like there's both. So in this point, the backcast output means like this. Then fully connected layer, like such as neural network, try to capture the patterns in time series data. And then backcast means that this stack captures patterns on this block. And the focused output means like next time steps patterns. So that is different by the focused part and the backcast part. And then the residual means like they just throw away from the input and the output backcast parts. And then that means that the patterns that the neural network failed to capture. Like my explanation is not clear, but please just make simply, just think simply. Okay, and then each stack is divided into generic and seasonal and trend stacks, depending on the block structure.
So I have to explain structural stack. People include.
Oh, I will explain later then.
Later.
Yeah. Slide, I think. Each stack has each block, several block, and then when we design the block like just general parts, then the stack is just coming out. We can design the stack as a generic stack. But when we design the block as a trend, then or the seasonal block, then the trend or season stacks are coming out. We can design the stack like this. Okay, then the generic stack applies the block function G using fully connected layer like this. Then when we have input data points, 15 input data points, then they embedding the input data into the hidden space, and then they try to capture the patterns on there. And then in the backcast output layer, they print out the captured pattern, and then the focused output part, they print out the patterns of the next time step. So in this part, they designed the block function G as a linear projection function like this. Okay, is it clear?
That is the definition of block.
Yeah. Stack have several blocks like this, and then each block structured as like this layer. Okay. But however, trend stack applies the block function G as a trend function like this, then of course the fully connected stack try to capture the patterns on here, and then look at these parts. They define function G as the focused matrix, like they design function G to be the polynomial of the small degree P of functions slowly varying across a focused metric like this. Then the backcast output is coming out, the trend of the captured patterns, and then the focused output is they print out the trend of next time step.
Sorry, could you explain more about the differences between the generic block and this trend stack? I think the overall structure looks same.
Yeah, overall stack structure is same, but in this G part, the G model G, they designed the model G as a fully connected layer. In the trend stack, they didn't apply the fully connected layer. Just apply from some predefined polynomial metrics like this.
And then do they do some same rule or different? They have different purpose?
Yeah, they train the model is the same way, but they just define if they design function G as a fully connected layer, that means the generic stack, and then they give some trial polynomial something, then the stack is going to the trend stack.
Did they? This is some detailed part of the architecture, and the overall main. It's like kind of like every architecture in here is kind of stacking several blocks. Output. So each block has two outputs, and one output goes directly to the output, and another output goes to next stack.
Next stack. Yeah.
Did they mention any rationale for this kind of architecture? So what advantage is kind of stacking?
Oh. Later that the slide is coming
okay.
soon, then I will explain more about it.
And another question. So this is kind of the smallest building block of the architecture. And also this has some backcast, forecast interaction.
Yeah.
And also this block has several types, which is generic, trend,
and seasonal.
And here you didn't think about seasonal in this trend function. The key difference from generic and this trend is only the last part.
Yeah, just the last part. Yeah, same as the seasonal stack too.
And so I missed the previous part. So generic was linear projection. So D here, eta is the output of fully
connected layer, and then there is one more fully connected layer.
Okay, one more fully connected layer.
Yeah.
Uh-huh.
They mentioned this fully connected layer as a just linear projection.
Okay, yeah, maybe we can think that. And in some sense, so generic block has more degree of freedom than trend. So trend is more smooth function.
I think so.
Yeah.
Okay. And then Let's see the seasonal, the trend stack, and let's see the seasonal stack like this. Then fully connected FC stack try to capture the patterns like this, and then they define function G as a periodic function, and then they define the output layer like this. Then backcast coming out the seasonality of captured pattern, and then focused part, they print out the seasonality of next time series time step. Okay.
Could you explain exactly this? How to distinguish trend and seasonal? Some detailed definition, definition about trend and seasonal. So and why we can use that science and
Because they try to apply the times period series, so that they just apply the sine and cosine in this moments in these parts, and then they try to capture the seasonality.
only for seasonal.
Huh?
Seasonal monthly.
Yes.
Seasonal.
They,
Maybe can we just get it as this high frequency of
Yeah.
distinguish trend?
Yeah.
Yes.
And this model architecture hierarchically decompose time series data for effective analysis. Like in the stack level, the input time series data is hierarchically decomposed using multi-stack structure. And then the block level, they remove the patterns captured by previous block, and the next block can more easily capture the remaining pattern because they use the residual connection block. And then in the layer parts, layers are constructed using inductive bias, including polynomial basis for trend and Pharisees for season, like this. And then they do another rules by stack level and block level and layer level.
One question is, does one stack has three types of blocks or one stack has only one type?
This depends on what's custom.
So doesn't matter.
It doesn't matter.
I have a question. I was wondering that is the number of the stack is also customizable, or it depends on some window size or time series?
No, this depends on the hyperparameter. And let's see the performance of the Embeds model, which this architecture Embeds model achieve the best performance comparing to baseline model. And this is the benchmark data sets when they are in the time series testing field, which named M3 and M4 and tourism. And they have multiple domains, like industrial part and economics part like this. And then they have several time series data inside of each benchmark data set. And then they apply some different metric named SMAPE that is modified based on the MAPE, which means absolute percent error. And they use this kind of metric to calculate the baseline model. And they custom several models. They just only construct the Embeds model with generic basic block like this, or they named like Embeds I, and that means that they construct the Embeds model with seasonal and trend stack like this. And they named Embeds I plus G, that means the ensemble model of n bits G and n bits I model. Then in this table, then specifically n bits I plus G model achieve the best performance comparing to the baseline model. Then in summary, n bits model, this is not correct, but they use the hierarchical decomposed time series data using multi-stack structure, and they remove the captured pattern, and the next stack try to capture the remaining pattern using residual connection. And then in the interpretable parts, then they constructing the layer using individual inductive bias makes output interpretable. Okay, and then in our application part, we can use for the wearable data analysis, time series decomposition is implicitly applied through the learning mechanism, or for wearable data analysis, time series decomposition is explicitly applied through the model architecture, I think. That is the summary of my presentation. Okay, then let's move on to Q&A time.